Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 25 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 120, triangle. So I'm going to solve this problem using two approaches. So first, let's read the problem statement. We have given a triangle array. We have to return the minimum path sum from top to bottom, right? And for each step, you may move to an adjacent number of the row below. More formally, if you are on index I on the current row, you may move to the either index I or index I plus 1 of the next row, right? So here, if you see this example number 1, so this is my triangle, right? So 2, then 3, 4, then 6, 5, 7, then 4, 1, 8, 3, right? So here, for this particular example, output is 11. So how this 11 is coming up here? So see, first I'm going to choose this 2, then I have two choices. I can choose this 3 or I can choose this 4, right? So among them, I'm going to choose, let's say 3. So if I'm choosing 3, right, so again I have two choices, right? So for 3 I have two choices like this, 6 or 5, right? So these two are the choices. So let's see if I pick 5. So now for 5 I have two choices, that is nothing but 1 and 8 now, right? So from current row, if I'm at index I on the current row, you may move to the either index I or I plus 1 of the next row. So this is what it's saying, right? So here for 5 the options are 1 and 8 only, not 4 and 1. So for 5, because 5 is at index this index 0 1 1 index, right? So here if you see this particular example, right? So for 2, we have choices like 3 and 4, right? Same way for 3 choices are 6 and 5. For 4 choices are 5 and 7. For 5 choices are 1 and 8. For 7 choices are 8 and 3, like this, right? Clear? So this is how we need to calculate, and what we have to return, we have to return the minimum path sum from top to bottom, right? And here in this example 2, only one value is there, -10, so we are just simply going to return this. And if you see the constants, so triangle dot length from 1 to 200 and triangle 0 dot length is equal to 1, right? And triangle I dot length is equal to triangle I minus 1 dot length plus 1, right? So it is given like this. So here what does it mean? Triangle I dot length. So triangle I dot length, so let's say your third row, right? So third row, so what is the length of third row? It's 4, right? So this length 4, right? So here if I write I minus 1, I minus 1 is 3 minus 1 2, so triangle 2 dot length is nothing but 3, right? So I3 for this one, 3 plus 1. So always if you see the row size 1, then 2, then 3, then 4, right? Initially for this row size is 1, then 2, then 3, so it is always incrementing. So that's the meaning of this line. And triangle ij values is from -10 to the power 4 to 10 to the power 4, right? And this is a follow-up question: could you do this using only of n extra space, right, where n is the total number of rows in the triangle, right? Okay, so here first let's understand the first approach, right? How I'm going to solve this problem using first approach, using recursion and memoization, right? Since I'm going to use memoization here, so in that the space that I'm going to use is going to be of n square, not just n, right? So first we will see the simple approach, then we will solve this problem using of n extra space, right? So here how you need to do solve this problem. So initially you are here, right? Initially you are here, so you have two choices, right? 3, right, and 4. These two choices are there, right? Now let's say if you are here, then you have two choices, 6 and 5, right? Clear? Now let's say if you are here at this particular 6, now you have two choices again, 4 and this 1. And see, this is the last row, right? So from here what I'm going to do, from here I'm going to return 4, right? And from this side I'm going to return 1, right? So among them, what is minimum value among 4 and 1? What is minimum? So minimum is nothing but 1, right? So here we have 6, right? And below that we have 4, and here in the right side we have 1. So I'm going to use this one, right? So then the total value that I have at this particular position is going to be 7, right? I'm writing it in box. 7 is the value, right? So here I'm saying that at my DP second row 0 column, I am fixing value 7, and this 7 is nothing but the combination of the value at this particular position 6, and below that whatever the minimum is there, right? So minimum is 1, right? So we are going to use this one, 6 plus 1 7. So I fix this value, right? Okay, so now here we solve this part, we solve this particular part, this 6, we solve it. Now for this 3, I know from one side 7 is coming up. Now I have to solve this 5 part as well, right? This 5. So again I'm going to check. So here for this 5 I have two options, this and this, right? So this is the last row. So from here I'm going to get 1, and from here I'm going to get 8, right? So among them, which is minimum? Minimum is 1, so I'm going to add this 1 to this 5. So what is the total value I'm going to get here? I'm going to get 6, right? So here I'm going to write 6 in the square box. So here that simply means dp 2, right, second row and first column. So here I'm assigning this value as nothing but 6. Clear? Right? Now from here, if you see, from here, from this side, for this particular 3 I'm returning 7 from here, and from this side I'm returning 6 from here, right? I have already solved this complete branch here, right? This 5, 1 and 8, this I have solved. 6, 4 and 1 I have already solved. So from here I'm getting 7, and from here I'm getting 6. So what is the minimum value here? So minimum is 6. So 3 plus 6 is nothing but 9. So I'm going to write 9 here in the box, right? So here this is nothing but dp1 comma 0. So here I'm writing dp1 comma 0 is nothing but 9, right? Done. Right, now I move here. So for this 2 I'm returning 9 from this side. For this side I have 4 now, so I have to solve this 4 part as well. So for this 4, what are the 2 options I have? I have one option is this and one option is this. Now see carefully one thing. I have 2 options, right, for this 4, right? So let me use this brown color pencil. So this is one option and this is one option, right? So now for this 5 here, if you see, I have already got the result of this complete subtree, like 1 and 8 and 5. So this complete, I already know the result here. I have stored, right, 6. So that simply means from here I can simply return 6, right? I don't need to solve this 5 and then I have to check 1 and 8, then among the minimum, and then do 5 plus 1, then get 6. This 6 is already there, right? I have already stored there. So that is the purpose of memoization, right? So that's why we use memoization. We don't need to recalculate the same thing, because I know from 5 I'm going to get the 6 only here, the updated value, right? Now from here I'm returning 6. So now let's solve this 7 part. So for this 7, again I have 2 options. I haven't recalculated this 7 in the past. So 8 and 3, last row, minimum is 3. So here I'm going to write 10 in the box. That is nothing but dp2 2, right? So dp2 comma 2 value is nothing but 7. That's it, right? So no, 10, value is 10. So here 10, right? This value is 10. So now if you see, from this side 6 and 10, these 2 things are returning, I'm returning to 4. So I'm going to use what? I'm going to use 6 here, minimum. So 6 plus 4 is 10. That's it. So now this 10 I'm going to return to this 2 from this side, and this 9 I'm returning from this side. So among the minimum is 9, right? So I have to take 9, and 9 plus 2, the value here, so that is nothing but 11. So for this one my output is 11. So that is my first approach. Very easy, right? Now let's write the code for this one. Let's not waste any time and let's write the code. Very simple approach, right? So here what you need to do first, this is nothing but list of integer, right? Like this. So first let's calculate the size. So int n is nothing but this array list, right? So we have to use this triangle dot size here, right? And then after that I'm going to use dp, right? So here I'm going to create this dp. This you can name it as memo as well, right? No issues. Just a naming purpose I'm giving dp here. So new int, and here I'm writing n and n, right? So here because of this the space complexity is not O of n, but it is O of n square, right? But we need O of n. So this is the follow-up. We will solve this problem using this one as well, right? So first let's solve this. This is very basic. So from here I'm just going to use my helper method, and in helper method I'm just going to pass this triangle, and I'm going to pass my current row. Current row is nothing but 0, and current column is 0, right? Because I'm starting from here, this value, right? This value 0, 0, right? And here I'm returning from here, and here this is my dp, right? Now let's write the helper method. So here I have to write private int, and here helper, and here let me just copy this. We have to pass this, and after that we have to pass row, we have to pass column, and we have to pass this dp. So let me just copy this, right? So by default all the values are null in this dp. That is why I'm using this integer, right? That is the purpose of this, right? So here I have signed all these things, right? All these parameters I pass in my helper method. Now here do one thing. I can create one common value here, or I can just I can pass this n value, or I can just do this, no issues, right? And here what we need to do here, I'm just writing one base condition, that if my row is final, n minus 1. So if my row was final, then what I was doing here, I was returning, right, 4 and 1 final row. So from here I'm returning 4, from here I'm returning 1, right? So if my row is last one, n minus 1, then just return triangle dot get the value at this particular row and get the value at this particular column, right? So in my array list we have rows like this, and then inside these rows we have columns like this, right? So get row dot get col, I have to write it like this. And here I'm just going to check one more thing, if I haven't pre-calculated this value or not, right? So if dp of row call, right, in the starting this value is null by default. So if it is not equal to null, then in that case that I have already calculated this value in the past, right? So from then what I have to do, I have to just simply return dp row call here, row, and here column. That's it. So this is done. And now here every time we have two options, right? So we are moving down and we are moving down right, I can say down right. So here if I am moving down, so I have to pick the current value, whatever the current value, right? In this value only we have to do the addition, right? So I have two choices, right? So I'm starting from here, right? So I have to pick this. Now from here I have two choices, this and this. So here I'm staying in the same column, and here I'm moving to the next column, and my row will be incremented, right? So what I'm going to do here, I'm just going to call my helper method. So this is my helper method, right? So I'm just going to simply copy this here, and same way I'm going to copy this here and paste it. But now here next time my row, right, so it is going to be row plus 1, row plus 1, and my column for this one I'm going to keep it same. And here next time for this one, if I'm moving to the right side, so row is going to be incremented and column is also going to be incremented in this case, right? So these two things, right? So this is what I'm doing, right? And from these two choices, right, I have two choices, right, for this side and this side, two choices, this side, this side. So I have to take the minimum, right, whatever the minimum I'm going to get. So here I'm just going to return what, math dot min of this down comma down right. Okay, this is done. So I'm returning minimum, and let's store this value in this dp as well, right? So in the dp I'm going to pass the value whatever we are going to get, right? So here this is what we are doing, right? And these values are coming from dp only, right, in the end, right? So very easy, right? Now let's run the code and see if the code will try to fix that. So see, all the test cases has been accepted, right? Now let's submit it. So see, our solution is accepted, right? Clear? So this is my first approach, right? So in this space complexity is nothing but of n into n, right, and n square, right? And same way for this time complexity is also going to be of n into n only, right? So since you are checking all the elements, right, so you are iterating over all the rows and columns one by one, so you can say the time complexity is also of n square, right? So like for this I'm choosing these two, for this I'm choosing these two, but if I choose this, then also I'm checking all the elements, so I'm checking all the rows and columns like that. So that's why I'm saying the time complexity is of n square for this one, right? So this is our approach 1, right? So now let's move to the approach 2. So in approach 2 I'm not going to use this 2D 2D DP array, right? So let's solve this problem using our second approach. I'm not going to use this recursion memoization. I'm simply going to use one single DP and using iterative approach, right? So let's see how I'm going to solve this. So first, for this problem, what you need to do, you have to create one DP, right? So let's say this is your DP. This is the first thing that you have to do. So I'm creating just one DP, right? Int DP, and this one is having same length as the number of rows we have, right? So total 4, right? So here this is what I'm going to do, and from this is the last row, right? From this is the last row, right? So in the DP I'm going to fill all the values like this, 4 1 8 3, done, right? So now from bottom I'm going to start the calculation. So next time this is my row, this is my row 657, right? So 657 is my row. So what I'm going to do here, I'm going to bring this 657 here, right? So now here if you see for 6, right, if my element is 6, right, so this and this, so I have two impacts, right? I can create impact here and here, right, from these two, right? So 4 and 1, whatever, what value is minimum here? Minimum is just 1, right? We have 4 1 8 3, right? Minimum is 1, right? So what I'm going to do in this value, I'm going to use this 6, right, this is 657 we have. I'm going to use this 6. So 6, if I do addition with 4, I'm going to get 10, and 6 if I do addition with 1, I'm going to get 7. So 7 is the minimum, right? So I'm going to update this value as 7. This value is 7 now. Done. Clear? Now same way for this 5, this 1 and this 8. So among them 1 and 8, so minimum is 1, right? So 5 plus 1, 6, right? So 6 is the value that I'm going to place here. 6, right? So only DP I'm updating here, right? So initially 4183, then 6, right? We have, so 6 for 6 I'm checking 4 and 1, so minimum is 1. 6 plus 1, 7. So 4, 5, 1 and 8, minimum is 1, so I'm updating 6. Now same way for 7, we have 8 and 3, right? 8 and 3, so among them minimum is 3, right? So 3 plus 7 is 10, so I'm going to update it 10 here. So this is done, right? Now after that, this 657 is done, right? Now after that, I'm going to pick this 3, 4. I'm going to bring this 3, 4 here. Okay, this is just for representation, right? I'm bringing 3, 4 here. Now again, if you see, for this 3, again we have two options, right? This and this, right? So 3 plus 7 is 10, and 3 plus 6 is 9. So I'm going to update this value as 9 now. So here I'm operating it 9, right? This is done. This is done. Now after that, we have this 4. So 4 is going to be impacted by this 6 and this 10, right? So right here for 3 we have this and this. So at this particular place we have what we have from the last time we have 7, right? Here from the last time. Same way for this 5 we have 1 and 8, so we have 6 from the past, right? So here that is why 6 is coming. 6 and 7, so from here we have to bring 6, right? 3 plus 6, 9. But for this 4 we have 5 and 7, right? So for this 7 value that is coming out here is 10, right? 10 and 6 here, so that is why 6 and 10 you are seeing here, right? So that's what I'm saying. So for this 4, 6 and 10, so from them whatever the minimum, just choose that. So 6 is minimum, 6 plus 4, 10, so you have to update it 10, right? So that's it. This is done. This is done, right? So now let me just remove it. Now next time, this is the one, right? So if you see, this is the one, right? So I have to just update 2 here. So now 2 is impacted by this 9 and 10. So, and that is true, 9 and 10, because this 3 value, 3 is taking 7 and 6, so among them 6 is minimum, so 9 here, and 4 is impacted by 5, 5 here, 6, and here 10, so 6 and 10, so 10, right? So here among them minimum, right? 9 and 10, so that's right, 9 and 10. I have to find out minimum. So minimum is a 9, so here I have to update 11, right? That's it. So in the end you have to just return this value, that is nothing but 11. So add dp of 0, this is the value that you have to return. So very simple, nothing complex here. So what you need to do here, dp, right? So I'm just going to remove this. I'm going to create one dp, and here I'm going to remove this, and here I'm just going to write new int, and that's it. And here I don't need all this stuff, right? So I'm just going to remove everything here. And now here if you see, this is our current code. So I'm going to initialize dp with the last row of triangle. So for that purpose, I'm just going to write one for loop for int j is equal to 0 and j is less than n, and here j plus plus. And now inside this I'm just going to update my dp of j. So dp of 0 1 2, right? Like that. So here I'm going to write triangle dot get, so last row, right? So n minus 1, and here I'm just going to write get j value. So this is how I'm going to update dp first, and once this is done, then after that what I'm going to do here, after that, let me format the code. It's not getting formatted. What's the issue? Okay, I think one is missing, right? This one. Now let me format it. Now it's looking good. Okay, so now this is done. Now after that we have to just do simple bottom up calculation, bottom up calculation, right? And here very simple, this one, for int I is equal to n minus 2, n minus 1 we already know, right? We have used that. So here this value until, for this is how we are moving, right? So for this 3, then we calculate for 2, then we 1, then you 0, right? Like this. So this is where I'm assigning the rows, right? And then for j, how we are moving, so int j is equal to 0, right? So like I'm updating 0 1 2, right? So for this 2 I have to update from 0 to 2. For this 1 I have to update from 0 to 1. So if you see blue color pencil, so for blue color pencil I was changing the values until this range. For this orange color or red color pencil we are updating like this, and in the end for 0 we have only 1, so I'm updating this one value. So this is nothing but your j, right? So int j is equal to 0, and I'm going to say j is less than equal to I, and here j plus plus, and here you have to write dp of j is nothing but triangle dot get value at I dot get value at j, and here you have to just do the math dot min of dp of j value, right, and dp of j plus 1, right and down, right. That's the meaning of this line. That's it. And in the end you have to simply return dp of 0 here. That's it. Now let's run the code and see if the code will try to fix that. So see, all the test case has been accepted, right? Now let's submit it. So see, our solution is accepted, right? And for this one also, type complexity is going to be of n square, and the space complexity this time is of n, because we are just using this one extra space, right? So here we are able to achieve this. We are able to solve this problem using of n extra space, where n is the total number of rows in the triangle. That's it. So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in the comment section. Till then, keep coding and keep practicing. We'll see you in the next video. Thank you. Bye bye.